we're going to look into question 3 of 2025 paper 2. Again, it is regional center paper, RC paper, so please take note and grab the right one. So we're going to look into the last 3 marks of question 3, and we're going to start off with something really easy. We start off with an equation that is hardly seen in this syllabus, okay? They show you potassium permanganate and it tells that it's undergoing thermal decomposition. It's quite clear because you start off with one substance and you break down into two or more. So in this case, it broke down into 3 things, and one of them is our oxygen gas, right? So first question here is describe gas to show that oxygen gas is produced. So in this kind of experiment, if you do get gas, how are you going to test for this oxygen, right? So first you need to ask yourself, what is the reagent? In this case, for oxygen, we want to use a glowing splin. So take note, some incorrect answer that I do get to see is lit or lighted splin, okay? And that is a wrong answer because lit or lighted splin is actually for hydrogen gas. So take note of this. Okay, so the correct one should be glowing splin. So this alone get you the first part. Okay, but again, because it's only 1 mark, so you won't get full mark here. So then what will happen to the glowing splin when you test it with it? It will start to rekindle, or another word that you can use as an alternative word would be relight. So at first there would be just a glow at the end of it. If I can just draw out for you. Okay, so it's just a little bit of glow here, but once there's oxygen present, it will start to light up again. Okay, so that's what we meant by rekindle. Next, we need to calculate the MR of K2MnO4. So for this kind of question, all you need to do is to use the periodic table, and again, you need to use the mass number of each substances. Okay, I'm trying to find my periodic table now, so obviously you see there's a blank there. Okay, manganese. Okay, manganese has a mass of 55. So this 39, they actually belongs to potassium because there are 2 potassium, so we've got 39 plus 39, and then manganese is 55, and then we've got 4 oxygen. Every oxygen is 16, and there are 4 of them, so you will get 197. Okay, finally, we are looking at the hardest question in this question 3. Telling you that potassium permanganate is an oxidizing agent. You need to give a reason why it is an oxidizing agent. So you do need to pause and ask yourself, what is an oxidizing agent? So this is the definition of an oxidizing agent. But it will not get you any marks if you write down the definition because they are not asking you to define what an oxidizing agent is. You need to prove that it is an oxidizing agent. Okay, so understanding that an oxidizing agent oxidizes others but itself get reduced at the end of the day. Now, what is reduction? So if you can pause and ask yourself, what is reduction? Reduction is actually loss of oxygen or gain of electron. Okay, so you're going to use the information above. The only thing that's provided for us in this case is the equation at the top, which is this one. Okay, how do I know that this is potassium permanganate is an oxidizing agent? You can see very clearly that at the end of it, it gives out oxygen, right? This is oxygen, so it loses loss of oxygen. Okay, so it gives out oxygen as a gas, so there's a loss of oxygen over here, and that's what we meant by using the context of the question. The jet that passed by, hopefully it's not too loud. Okay, so this is what we meant by loss of oxygen, and so using this, you could just simply word it out like that. Potassium permanganate loses oxygen, hence it undergo reduction, or you could say that potassium permanganate undergo reduction because it loses oxygen. Okay, I understand that some of you might be curious, can we apply the idea of gain of electron over here? Yes, you can. Okay, you can just simply say that potassium permanganate gain of electron since it undergoes a reduction. But understanding of the gain of electron might not be as easy as it seems because you need to understand what we call a half equation. Okay, so I've just simply doodled out the idea of how you can see that it gains electron here. The potassium permanganate that we start off with has an oxidation state of +7, and it eventually becomes oxidation state of +6 and +4 respectively. So there is a gain of electron over here. Okay, so the +7 gain 1 electron so that it becomes manganese with oxidation state of +6, and the other one, it actually gained 3 electrons to become manganese with a +4 oxidation state. So it is not as easy, in my honest opinion, to write the electron definition, but I'm just writing out or doodle out the basic understanding of what I have. Okay, this is the biggest clue of why potassium permanganate is acting as an oxidizing agent. Again, giving the definition will not score you any marks here. I know this is only 3 marks here, but hopefully it helps you to better understand how to approach a definition question versus an explanation question. And for the last question on oxidizing agent, we are not asking for definition, they are asking for an explanation, quoting a reason, giving a reason, and the only way you can do so is again using the context, and that's the balance equation there. Alright, hopefully this has been helpful. If it is, give me a like, subscribe to this channel, and then share with a friend. Alright, see you in the next one.